So next, I will teach you about total resistance in parallel connections. Okay, do you know what's the definitions of parallel connections? How do you explain in words of things that are connected in parallel? So let's take 3 resistors again. Well, many of you now, I think, realize, okay, you see it right there, and it's in parallel, right? But what exactly is the definitions? Some of you may say, well, oh, the top and the bottom are the same point. Yeah, it's correct also, right? When things are connected in parallel, your top node at the top and the bottom nodes are the same point. But there is a better and clearer definitions, that is, whatever things are connected in parallel, the voltage drops across it are the same. So this voltage drop across R1 would be V. Across R2 is also V. Across R3 is also V. So in other words, as I mentioned before, the nodes at the top and the bottom are in the same spots, okay, place. And you have also learned that the formula for R total, right, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, and of course, if you have the number n of r's, it would keep on adding 1 over R4 plus 1 over R5, continues. Of course, there is a so-called derivations of derive how this formula come from using Kirchhoff voltage law and Kirchhoff current law. Okay, and in addition with, of course, Ohm's law, which we'll talk later. Okay, so therefore, let's see if in this case, the example I'm going to give you is that I will assign R1 equal to 2K ohms, R2 equal to 5K ohms, and R3 equal to 500 ohms. Very diverse, the values, okay? So anyway, we have calculator, we're not scared. So our total is 1 over 2K plus 1 over 5K plus 1 over 500. When you press it into your calculator, the answer is 370 ohms, or equal to 0.37 K ohms, like this. All right, so that's that, and we will show you with the actual circuit. Another thing I want to point out to you, okay, is that in case that you have, let's say, 2 resistors in parallel, or let's say, okay, if you have n numbers of resistors connected in parallel and they are the same values, n times, okay, 1 times, 2 times, n times, same value. So R1 equal to R2 equal to R3 equal to Rn, and the value is R. Your R total, if you look in there, okay, your R total is equal to R over the number of resistors you connected in parallel. So therefore, let's say if I have R is equal to, let's say, let R equal to 1K ohms, and I connected with just 2 of them together, like this, right? 1K parallel with 1K, and so therefore, my answer R total would be 1K ohms divided by, well, there are only 2 resistors, so divided by 2, and the answer should be 0.5 K ohms, or equal to 500 ohms. Right, so let's see. Okay, so let's see how it works in the real circuit. Okay, now, 3 resistors. Let's look at this one first. 3 resistors, okay, R1, R2, and R3. So I assigned it that R1 is equal to 2K ohms. So let's look. The 2, yeah, so about 1.9. It said 1.9, right? You have to realize that there's a little letters right there, K ohms, right, on the top after the number 5. So 1.9 K ohms. See this little one right here? Oops, gone. Okay, right? And second one, R2 is 5K. See? 4.9 K ohms. And R3, I said it's 500 ohms. So 0.504 K ohms, right? So now I'm going to put it in parallel, 3 of them in parallel. So therefore, the node, one of the node has to be in the same, same position. So the second at the other end also. So I'm going to move it such that now they are connected in parallel. So right now I'm going to, let's see, I'm going to put the probe across the first one. Let's see how much do we get. We're supposed to get our total right away. And the answer is supposed to be, what is it? 370 ohms or 0.37. So about, yeah, it's a, I think my hand's shaking. Right, so 37, something like that. Let's say the second one. Right, about that. 0.3937, and this one here, 0.48, yeah, there you go. It just, fluctuate. There you go. So it shows that when you, this is what it is when you put them in parallel. Okay, now the next one I said was that if you have 1K and 1K connected in parallel, right, the value should turn out to be 0.5 K ohms, right? From the example. So I have 1K right here, right? Okay, let's, if you want to see that I'm not tricking you, so 1K here, 1K, there, 1.1, 1.0 right there. And this one here, also 1, right? There you go, 0.97 also. Now, put them together in parallel. And it's supposed to be 0.5K. There you go. All right, okay. So that's that for total resistance in parallel. Thank you.